Welcome back to Calculus. I'm working a problem from section 5.1. This is a logarithmic differentiation problem, so the reason we do this is because I want to take the derivative of this function, but it's difficult to take it in its current form. So this is just telling us that you do have the option of taking the natural log of both sides. And when I do that, it's going to be a little bit easier to take the derivative. In fact, it'll be really easy. If you know how to take natural log derivatives, that is. Okay, so let's, before I even use the power of the log, I'm going to take my time here. I mean, this is a video, so you can always fast forward me if you want. But just to make sure I don't lose anybody, that's a 1/2 power, right? Okay, now the power of the log says you can take that 1/2 and put it out front. So we'll do that. So 1/2. And we better put a bracket here to show that, and I guess I don't really need a bracket yet. 1/2 natural log of x squared minus 1 over x plus 1. And I have one more log trick up my sleeve, and this is where I need that bracket, because I'm going to take this quotient and turn it into a difference. So the difference of two natural logs. So what I've done now is on the right side I have these two terms that aren't nearly as complex as where I started, and now I'm ready to take the derivative. I'll switch colors again here as we take the derivative with respect to x. Just to make this a little easier though, I'm going to use just the y prime notation. Let me back up on that. So the derivative of natural log of anything, you throw the thing in the denominator, in this case y. The numerator is where the derivative goes. And the derivative of y, we're just going to say is y prime. And that ultimately is what we're looking for, right? Now I take the derivative on the right side, I put the thing being natural logged again in the denominator, the derivative up top. Keep the minus, the thing being natural log in the denominator, the derivative up top. Okay, I basically have the derivative. But let's get y prime by itself, so I'm going to multiply both sides by y, and as I put it on the end here, I'm going to go ahead and get a common denominator. So what does this top term need? It needs an x squared plus 1. The top left term needs an x squared minus 1. This is looking pretty good. And of course my y, don't forget that. Let's simplify. Get that little mark off there. Okay, so we simplify. This will be 2x cubed plus 2x minus 2x cubed plus 2x. And I will say, my first time I did this problem, I multiplied. I was so excited. These are conjugate. This is going to be so nice, but it's actually not quite as nice as if you just leave them separate. We'll see why later. Okay, so y, I don't want to leave it as y. What is y? If we go up here, we see that y in the beginning was this square root of thing, okay? So square root of x squared plus 1 over x squared minus 1. This now can be written, because these 2x cubes cancel, just get 4x on top. I wish I didn't have to make that clicking sound. Sorry about that. And then let's write this as 1/2 power. Remember that this is a 1/2 power. Maybe I should have done that earlier. Oh well. Taking my time here. Right? And actually I can cancel this 2 and that 4. So we end up with 2x this in the denominator still. But now, this 1/2 power, it is okay to take the power of the numerator and denominator separately. And the reason I'm doing that is because then they can join forces with the other portion. So let's see if I can make this with some colors. This one and this one can come together to be, let's go back to blue. to be x squared minus 1 to what power? That's right, 3/2. And then this one and this one are actually going to have some cancellation. This is gone, and there would be 1/2 left here. What it's like doing this. Y to the 1/2 over y is the same. When you divide with the same base, you subtract the exponents. What am I doing here? So it's 1/2 minus 1 or negative 1/2. But that's the same thing. It's just 1 over y to the 1/2. So they cancel. Probably the easiest way to see it. Half of this part up here cancels. Half of it's all gone. And so it takes with it half of the whole here. So that's why the denominator just has left x squared plus 1 to the 1/2. And then there's a 2x up there too. So like I said, the first time I did it, I multiplied out the denominator, but it actually had more x's, so I like this form better. It'd be okay if you multiply it out, I think, in the end. But just a quick summary of what we did. They said use logarithmic differentiation, which says we natural log both sides. We made the square root of 1/2 power. We used the power of the log both. We used the power of the log here to bring that 1/2 out front, and here to separate this into 2 parts. Then I did the derivative, and you see that I had here, here, and here. I did the derivative of natural logs. We got some practice with that. Then I got a common denominator. I brought y over. I replaced y with what we said y was in the beginning. Simplified, and then this mess here that I made, I did some cancellation. And this is about as good as it gets. Hope that helps. See you next time.